The sun has been shining for about 4.6 billion years. But why hasn't it burned out?
It looks like a gigantic ball of fire, but the sun isn't actually burning like a fire on Earth. A normal fire needs oxygen and fuel, and eventually it runs out of both. If the sun worked the same way, it would have disappeared long ago. Instead, the sun produces energy through a completely different process called nuclear fusion.
Deep inside the sun, temperatures reach around 15 million degrees Celsius.
Under enormous pressure, hydrogen nuclei are forced close enough to fuse together.
During this process, hydrogen is transformed into helium, releasing an enormous amount of energy.
Trillions upon trillions of these reactions happen continuously inside the sun.
But that energy doesn't immediately escape. It begins a remarkably long journey toward the surface. A photon can be absorbed, re-emitted, and scattered countless times inside the sun.
This makes the journey from the core to the surface incredibly slow compared with the speed of light.
Once the energy reaches the surface, sunlight escapes into space at the speed of light. Just 8 minutes later, that sunlight reaches Earth and powers almost every ecosystem we know. Plants capture the sun's energy through photosynthesis, forming the foundation of most life on Earth.
We can even capture some of the sun's energy directly using solar technology.
So why doesn't the sun collapse under its own enormous gravity?
Because gravity pulls inward, while the pressure created by the hot plasma pushes outward.
This balance, called hydrostatic equilibrium, keeps the sun stable for billions of years.
And the sun has an enormous supply of hydrogen fuel, but it uses that fuel surprisingly slowly.
Only a small fraction of the sun's hydrogen is actually undergoing fusion at any given time. The sun formed about 4.6 billion years ago, and it still has billions of years of stable life ahead, but the sun will not remain unchanged forever. Slowly, it is becoming brighter as its core evolves. In about 5 billion years, the sun will run low on core hydrogen and begin transforming into a red giant.
The sun will swell to an enormous size, completely transforming the inner solar system.
Eventually, the sun will shed its outer layers, leaving behind a much smaller stellar core.
That core will become a white dwarf, slowly cooling over billions of years.
So the sun isn't burning like a campfire. It is powered by nuclear fusion.
And that's why the sun doesn't simply burn out. It is a gigantic nuclear furnace,